Next is case 2. When you do your substitution method, you substitute the value of x into your function fx. If you get 0 divided by 0, this is considered as case 2. And the aim of solving case 2 is to cancel out the same factor from numerator and denominator. So you'll do something to your function fx so that your function fx will have the same factor in the numerator and denominator, and hence you can cancel out the same factor. The first method in solving case 2 is to factorize. The second method is by using the multiplication of conjugate. So we will only use this method if you can see surds or square root. And for this one, the surd can either be in numerator or denominator. And you only have to expand the part with the conjugate. So you'll see more in the examples later. And sometimes you may also need to use both factorization and also the multiplication of conjugate. Example 2, question 1, find the following limits. This is our fx. So substitute x equal to 8 into x, and you'll get 8 minus 8 divided by 64 minus 8 square, which is equal to 0 divided by 0. The moment you get 0 divided by 0, you know that this is case 2. And for case 2, we can either use factorization or multiplication of conjugates or even both methods. So for this question, which method do we need to use? There's no square root, so we don't need to use conjugate, and hence the only other method is factorization. So we need to factorize 64 minus x squared. All the others remain the same. Here we have 64 minus x squared, so take out negative first. And now you can factorize x squared minus 64 as per usual. So remember, for case 2, you need to cancel out the same factor from numerator and denominator. So here we have x minus 8 and x minus 8. So now you just need to simplify. And now we can substitute the value of x into x. And the final answer is negative 1 over 16. Next, for question B, substitute x equal to 2 into x. So you'll get 2 cubed minus 8 divided by 2 square minus 4, which is 0 divided by 0. So you know that this is case 2. And for this case, you can either use factorization or conjugate or both. And if you look at this question, there is no surd, so there's no need for you to do conjugate, and hence we need to use factorization. So here we have x cubed minus 8 and x squared minus 4. So which one do we need to factorize? Factorize the one with the highest power. So we will factorize x cubed minus 8. So recall chapter 6 on how to factorize a polynomial px. We can see that here the degree or the highest power is 3. So whenever the degree is bigger than 2, we need to use long division. So we will do long division for this part here. Next, we have x times negative 4. So this is negative 4x. So put negative 4x underneath the term with x. And then subtract as per usual. and we'll get the remainder is 4x minus 8. The highest degree is 1 and the highest degree is 2 here. Therefore, we can see that the highest degree for the remainder is less than the highest degree in denominator. So we will stop here and write in the form of px over dx equal to qx plus rx over dx. So now we can see that x cubed minus 8 divided by x squared minus 4 is this equation. So this is our original limit. But now we can substitute x cubed minus 8 over x squared minus 4 into this expression. For case 2, we need to cancel out the same factor from numerator and denominator. So we're going to do something to this fraction here. For x minus 8, when you factorize, you'll get 4 times x minus 2. For x squared minus 4, when you factorize, you'll get x plus 2 and x minus 2. Cancel out x minus 2. So we haven't substituted the values of x yet into fx. That's why we still have limit x approaches 2. So now substitute x equal to 2 into x. And the answer is 3.